Okay, lesson 20. We're going to be learning about functions and dealing with function notation. Okay, a function is just a mathematical rule. In which each input produces exactly one output. And that's going to be an important thing, exactly one output. Okay, and we're just going to get used to function notation. So an example of a function, they like to use f as default, a lowercase f. If they have multiple functions, sometimes they'll use f, then g, then maybe h, which I'll do on the homework when I start trying to have you deal with multiple functions. And then it has a parentheses, and so I'm just going to throw it in there, x or any kind of variable. I'll default to x. And even though we're used to seeing two things next to each other being multiplication, when you see this in this context, it is not multiplication. This is your input variable. It's just specifying what your input variable is. Sometimes called a dummy variable. And then it's equal to, and then on the right side it tells you the rule that you're going to be following to get your output. So this is just an example. Our output we'll derive our output by doing 3 times the input squared, input variable is x, plus 2 times the input variable minus 8. So that's an example of a function. This is interpreted. So x is just replaced with a value or an expression even. So we're thinking of that x like just a placeholder, telling you where that placeholder is going to go. So whatever goes in that box is going to go there squared, 3 times that squared, plus 2 times that same input. It's going to be plugged in 2 different places, minus 8. Okay. So let me write it. So we're interpreting it this way. Okay, and let's get used to just doing a couple of these. So instructions are find the following. It's following up from this definition here. So if they want f of 2, so that's read as, and let me write that in your notes. When you see that and somebody wants to express it, they will say f of 2. Or the function value at 2 is a more wordy way of saying it, but people usually say f of 2. Alright, we're going to compute it now by literally doing what I said. 2 is going to replace that box there, and we're going to fill it in everywhere. So the idea is we're plugging in 2 into the function, and we're getting an output that we get by computing that. Let me write it out here. So we're going to have, following this rule, 3 times 2 squared plus 2 times that input of 2 minus 8. And then from there you just work it out. Follow PEMDAS. That's going to be 12 plus 4 minus 8. And I believe it's 8. Okay. So the conclusion here is when you input 2 into this particular function, this function f that's defined here, when you plug in 2, you get an output of 8. So they'll say f of 2 is equal to 8. The function value at 2 is equal to 8. Let me backtrack and label that A and do a B here. Okay, so just more practice, getting used to this idea. We're going to do f of negative 1. Now you have to be careful about negatives, but the principle is the same. We're going to plug in negative 1. We're going to watch the negatives. So I'll see if you can do this. Pause here. Be careful, the negative 1 is going to get squared when you plug it in there. And watch the negative when it's over here, and just watch your signs. I'm going to start though. 3 times x squared plus 2 times x minus 8. Negative 1 squared is positive 1 times 3 is positive 3, so that negative gets squared out. That negative does not. That's minus 2, and that minus 8 on the end is still there, so this is going to be negative 7. Okay, and then now I'm going to do more examples of this with multiple functions. I'm going to redefine f, so we use the same definition of f as long as there's no other f defined, but the next problem I'm going to introduce a new f, and so this one's gone, and it's a new f that we're going to be dealing with. I'm going to pause here though. Okay, we're going to let f of x, g of x, and h of x be defined as follows. Technically, your input variable could be any variable, and sometimes I'll use other variables other than x, but as we're just learning it, we'll default to your standard x as our input variable. But we're going to have 3 different functions, so I got to use different letters designated by f, g, and h. And I got to give you the definitions. So this is a new f entirely. You abandon that old one. And anytime you see f of something for the next few problems, you're going to work with this rule. Anytime you see g, it's a different rule. And anytime you see h, you're going to plug it into this. F of x is equal to 3x minus 2, g of x is equal to 2x plus 1, and h of x is equal to just negative 4. And we'll talk about that one, because that one trips people up. And the instructions are to find the following. Okay, so f of 2 has a value, and we're just trying to find that value. And it's different from the previous f of 2 because it's a different f we're talking about. So we're going to do it fresh and plug it into there. Following this rule right here, 3 times positive 2 minus 2. Okay, and you get 4. So f of 2 is equal to 4. You don't need to write it, I just want to, whenever I'm emphasizing it now, it just, that's a value which we don't know until we work it out. That value is equal to 4. F of 2 is equal to 4. Okay, but you can think of the 2 as your input and the 4 as your output. Alright, I'm not going to talk about all that for the remaining ones. We'll just grind out some of these problems and talk about how to combine things and compositions of functions. So it gets a little more complicated. But here, you're doing g of negative 4. Well, let me grab something real quick. Okay, so you find the definition of g is a different function. So this is the function we're using, different rule. We're going to plug it into that. Okay, 2 times negative 4 plus 1, plugging the negative 4 into there, and we get an output of negative 7. Okay, next. H of 3. H is over here. You're plugging in 3 in place of x. That's your input variable in here. Now note, there is no x over here, so you are not doing negative 4 times 3. This is not correct. That's taking the input variable and multiplying it by negative 4. It doesn't say to take the input variable and multiply by negative 4. So this would be what you do if you have negative 4 times x. You don't have that. In fact, you have no x at all. So plugging in that 3 in place of x here means there's nothing to do. Your output is just that. It's just negative 4, period. H of any number you input is negative 4. And that's it. D, H of negative 8. You take negative 8 and you plug it in for x on the right, but again, there is nothing to plug in on the right. It's still just negative 4. H of anything is just negative 4, so you don't do anything with this one. Again, you're not multiplying negative 8 times negative 4. It doesn't say to multiply your input variable. It just said is a constant output. So it's called a constant function. Its output is just a constant -4. H of anything is -4, the way it's defined here. Okay, so be careful of that. Comes up on the homework. Okay, I'm going to erase here. Same definitions, we're doing more. I'm on part E. We're going to do f of 2 minus g of -3. Okay, so you can have function values composed in different ways with different operations, and here it's subtracting two function values. F of 2 is just some value. In fact, I think we found it earlier, but let's pretend we don't even know it, but it has a value. We found it earlier. Minus right here, g of -3 has some value. So ultimately I'm just subtracting two numbers, but I don't know what those numbers are until I work out f of 2 and g of -3. Now, it is possible for you to put it in one line and work it out, but you'd have to introduce a lot of parentheses because this minus applies to everything related to g. I would just recommend a different approach. I will recommend us just doing two separate problems first, finding f of 2, just f of 2, and then later on after that, just finding g of -3. In fact, I'm going to do it on the side. No, that's fine. Sorry. I'm indecisive today. Okay, so I'm just going to treat it like two separate problems. F of 2, find the following, find f of 2. Plug in 2 into f, this row right here. And I get the same answer I had a couple of seconds ago, 4. That's not my answer, but I want to circle it because that's an important piece that I'm going to use later when I actually do this problem. Right now I'm just kind of doing the background on it, but I'm going to circle them to highlight the important things that come out of this step. G of -3. I'm going to plug in -3 into here. Is that the same one I did? No, it's not. 2 times -3 plus 1. It's -6 plus 1. It's going to give me -5. Okay, still not my answer, even though I'm circling it. That's not my final answer, because what I want to do is, the whole point of this problem is for me to find the value of f of 2 minus g of -3. I can't cancel those negatives because I'm not subtracting -3. I'm subtracting some number that I don't know that I have to figure out. I do know it now. Okay, so f of 2 is just some number. I'm going to replace it with that number. It's 4. G of -3 represents some value, which I don't know, or I do know actually. It's -5. Don't lose track of the operations. That minus sign is between them, so I'm subtracting this value minus that value. So ultimately I'm doing 4 minus -5. F of 2 minus g of -3. 4 minus -5. Alright, you do your usual canceling those negatives, and you get +9 out of this. Okay, so that's my recommendation for this approaching a problem like this with two function values combined via some operation is just spend some time just finding those two function values separately. Don't start trying to mix up things and canceling negatives or anything like that. Just f of 2 is some value, g of -3 is some value. They're used here, find those values first, and then do what it says to do with them, which in this case was subtract those two values. Okay, I'm going to erase. I want a lot of space for these. Just to do them carefully. The next one is going to be what's called nested functions, or more formally, a composition. You don't need to know that term, but I'm going to introduce it because they will use it. Composition of functions. There's also, this is the easiest way to interpret it. It's g of f of 3. Sometimes they're called nested functions because they're nested one inside the other. Composition, again, is a more formal term. And I do, even though I'm not going to use this, introduce a symbol that they do always talk about, and they introduce which is a composition symbol, which is an open circle. So that it's distinct from like a closed one. A closed one would be multiplication, but this open little circle between them implies that you're composing them in this way, f of x and then g around that. So if you do see that in another textbook or something or some other class, it means you should immediately interpret it this way. I've never seen people really use this a lot. Whenever people do see it, they just rewrite it like this because it's easier to interpret. So just so you know, there's a symbol specifically indicating composition, but it's easier to just put one inside the other so you know what you're doing. And what you're doing is, you're doing g of, not 3, you're doing g of whatever that value is, which we don't know. So f of 3 is some value, and that's, once we get it, that value is going to go there, and we're going to do g of that value. So we don't know what we're plugging into g yet. We have to figure it out. Just one more time. We're doing g of something, which we don't know, but what we're plugging in is whatever we get when we do, what did I just have? F of 3. F of 3. So I need to do one at a time, working inside out. I need to know what f of 3 is. F of 3 is just some value, which I don't know, and I didn't do it, so I'm going to do it. F of 3, again, is just some value. Let me figure out what it is. There's my rule for f. 3 times 3 minus 2, which is 7. Not my final answer, but again, I'm circling it because that's a value that I need to use in the next step. The next step is to actually do our problem. I want to do g of some value, that value being whatever f of 3 is. Okay, so again, you're working inside out. First we got to do f of 3. I already did it. That's equal to 7. Then g of that. So g is still there. We haven't evaluated g, but we're doing g of 7. Replacing f of 3, which is equal to 7, replacing it with actual 7, and now we're doing g of that value, g of 7. From there, it's just g of 7, 2 times 7 plus 1, which is 15. Okay, so that's composition of functions there. We got more problems to do, different types. You did some practice looking at that on the homework. And if you're stuck on them, just text me. What number was that? A, B, C, D, E, F. Was I labeling them? No, I don't know. We're on G, but I can't remember if I was consistent with that. Just organize these problems in whatever way you want. I've lost track of my organizational scheme. Okay, this is a new type of problem. It's still basically same function definitions, but we are not doing g of 7. We're doing g of some unknown, and we want it to equal 7. 7 is the output. I don't know what the input is. Input is unknown. And I need to figure out what input will give me an output of 7. I'm going to do my work over there. But basically, well, for now, I'm going to copy down what they just told me. I want g of x to equal 7. And g of x is equal to 2x plus 1. So whatever x is, g of x would be 2x plus 1. So I'm going to use the function definition of g of x, replace it on the left side, and I know I want it to equal 7. So I want to find the x that will make this equal to 7. From there, it's just solving. So you're setting up an equation. The function definition is equal to the output, and solving. Okay, and I get x equals 3. Okay, and that was something that no, it didn't come up. Okay. All right, I'm gonna do one more of these. Okay, pause there, get that down. run H. Go ahead and do this one on your own. Find x such that f of x is equal to negative 17. A similar process, different function. This is f this time. Same idea. They're giving you the output, not the input. So you're going to set up similar to this, but with f and negative 17. Pause here and make sure you can do this on your own. I'll start off with that, the actual expression that or equation they want us to solve. F of x is equal to 3x minus 2 for whatever input, and I'm trying to solve for the input, so I'm going to replace f of x with its definition. We know the output we want is negative 17, and now we're finding x, so we're just solving for the x that makes this true. I'm going to solve it rather quickly. It's the same thing we did way back, and we've done it many times now, so I can't really spend too much time going through solving. You add 2 to both sides, you watch your signs, you're going to divide by 3, and you've got x equals to negative 5. That's it. Just be aware that this type of problem is different. They're giving you the output, you're not plugging in anything, you're solving for the input. So you're setting up an equation to solving. Okay. I'm going to pause there. We got a couple more things to do. Not that much. This is a short lesson. Okay, next, I do want to get you used to the idea of graphing functions. Okay, so we'll do 2 of these. That should illustrate enough how we're going to approach this. F of x is equal to negative 2x plus 1. I'm going to leave space here because I'm going to do a table. I am going to approach this as just plotting some points. Now it's going to be, we've done graphing before, but we did generally x and y or other variables based on population and time or things like that. Here, x is going to be our usual horizontal axis. Our vertical will, however, be f of x. It'll be the output. Okay, and you're going to be given a grid on your homework. Let me just make a somewhat nice graph for this. Okay, and leave some room here because we're going to make a table and plot some points to see what this graph looks like. After we do that, we'll move on to graphing g of x is x squared minus 3. Ew. Again, leave a little space on the left side for a table that we're going to build. X is our input variable, that would be the horizontal. Our output or our vertical axis will be based on the output, which is the function value. And we did plotting points when we did lines, when we graphed linear equations, and then we got away from it because it wasn't the best way to approach it. And similar with functions, depending what function it is and how familiar you are with it, it may not be useful to plot points. There may be better ways to do it, but it requires you to really understand the nature of the function. This one, negative 2x plus 1, is a linear function because the expression or the rule on the right is a linear expression. You're going to go back to lesson 4 to remember we talked about and distinguish between linear expressions and quadratic expressions. Linear was of the form ax plus b, just an x and coefficients. Quadratic was of the form ax squared plus bx plus c, where you had an x squared term. So you have to write this down. I'm just reviewing. What am I doing? This one was linear. This one was quadratic. I'm just reviewing because I'm actually going to label those. This one is a linear function because it has a linear expression. This one has a quadratic expression. So this one is a quadratic function. I'm not going to test you on these terms, but it is kind of crucial that you, well, I don't want to say it's crucial, but it's very useful for you to distinguish between the two. Okay, so they're going to look very different. Oh, and I should probably mention now. No, I'll mention it later. Okay, so we're going to approach this by plotting points. Meaning I'm going to pick some x's, just like we did when we did lines and plotting points. Instead of y here, though, there is no y. But our function value, our f of x, our output variables will be like y. And when we graph them, we're going to graph them as x and f of x. So it'll be the same thing. We'll treat these like x and y pairs. They're just, it's essentially just y, but labeled differently. Labeled as f of x instead. Okay, I got to pick some x's. I haven't yet. I'm going to pick several. If you know it's going to be a line, you can just do 2 or even 3, but I'm going to pretend I don't know what it is. And I'm going to do some nice whole number values. I'll choose some negatives, some positives. So I'll be doing 1, 2, and -1, -2. So I'll get an idea of what the graph is looking like over here. And then I can speculate what it's going to look like beyond there. But if I wanted more points, I could just add more. Okay. And then, I don't really have space to do it, but I should just, okay. So, for -2, I'm going to find the value of -2. I'm just going to cram it over here. This value right there is literally what I get when I plug in -2 into f of -2. I'm going to plug it in there, watch your negatives. It's going to be +4 plus 1 is 5. So, f of -2 is 5. So that's going to be my first point. I'm going to plot -2 along the x and 5 along the f of x axis. Next one is -1. I'm plugging into the same function, -2 times -1 plus 1, and that gives me 3. Okay, I'm going to do the rest quickly, but it's the same idea of just plugging in different values into that. 0 in for x gives me 1. 1 gives me -1. 2 will give me -3. Okay, I'm not going to show the work for that. I'm not going to take up too much time in this video, but the idea is I'm just plugging in all those x's that I chose into the function and getting the output. Okay, let me plot these points. -2, 5 is I'm going -2 along the x right here, and 5 along the f of x axis, which again is just essentially doing the same thing as when you have a y coordinate of 5. 1, 2, 3, 4, 5 right here. Oh, am I off? It's hard for me to do it from this side. 1, 2, 3, 4, 5. Okay. Next, I'm going to plot -1, 3. -1, 1, 2, 3, right here. 0, 1. 1, -1. And 2, -3. Okay, and what it looks like is the points line up. And so this ends up being the graph of a line. That's what a linear function will look like. In fact, plotting points for a linear function is entirely unnecessary because the things we learned about lines and graphing lines applies to linear functions as well. It's pretty much the same thing as the line y is equal to -2x plus 1, except the y is labeled differently. So it's the same graph, just a slightly different label of f of x instead of y, as y is equal to -2x plus 1. And so, by all means, if you recognize it's a linear function, and the graph's going to be a line, you can use your slope and intercept. What I would have done there was figure out my slope is -2 over 1. That means I'm going to go down 2 and over 1. But I want to start my y-intercept, which is based on that plus 1, so 0, 1. So I would have started, if I graphed it that way, at 0, 1. And I would have gone down 2, and then over 1 and get that point, and then draw a line right through it and get the same graph. So you don't need to graph all these points for a linear function. You know how to do it in other ways using slope and intercept. Okay, I don't have enough room for this one, so I gotta erase. But be aware this is not linear. And I'll tell you right now that a quadratic function, the graph is a parabola. I'll write some notes after I erase that. Parabola is basically U-shaped. So let me clear this out. You can still plot points for this, it's just not necessary for linear functions. I would prefer it if you'd be able to recognize linear functions and when you can use slope intercept. And when it's a quadratic function. So let me just move this over here. Okay, so this is a quadratic function because it has a quadratic expression on the right, an x squared term. And I'll write over here, graph is a parabola. That's the formal term. You don't need to know, I'm not testing on it, but just to make sure that they'll use it in future math classes. It's a U shape sort of that goes up or down. Could go either way, but it's one of those. Okay, and you cannot use slope intercept because it's obviously not going to be a line, so here you have to plot points. This time it's g of x instead of f of x, but these are going to be like y values, and you are going to get them by plugging in, and I'll spend a little more time doing this one. Okay, so I'm taking the same values. I'm going to pick it around. I should have just left that up. Let's see. X is your horizontal, g of x, the function value, is your vertical axis, and I gotta just get some points. And I'm picking some nice round numbers, some negatives, some positives, so around the origin. So I'm picking that value, that value, that value, that value, that value, just so I get some negatives and positives and 0, and I can see what it looks like around there. And I'll be able to basically from there determine the shape. The problems you have related to quadratics are all designed where you can just use -1, -2, 0, and 1, and you should be able to get an idea of what the parabola looks like. Alright, let me start plugging in. I'm going to do g of -2 first. You have to be careful with how you handle this because -2 is replacing x. That whole thing is squared, so you need parentheses, even though it's not in the original problem. You need parentheses so that the person working it, you, in other words, knows that that negative is part of the base and therefore it gets squared. So it's going to be -2 times -2. X is -2, x gets squared, so you're squaring -2. That makes it a positive 4, and 4 minus 3 is 1. G of -1, very similar. You do need to worry about that negative. X is -1, x gets squared, so that -1 is part of the negative part of your base. It's going to be 1 minus 3 is -2. Make sure you understand those and how to handle those negatives. It is just PEMDAS doing exponents first, but that negative is part of the x, therefore it's part of the base that's getting squared, therefore you need to throw in parentheses. 0 squared is just 0, so that 0 minus 3 is -3. Real quick, 1 is going to be -2. I'm not going to do the rest. And this is going to be +1. Okay, I'm going to plot those points. It should form a U shape if one of them is way off from that. If you have a bunch of points that are like looking like a U shape and then one is way off, it doesn't do that, so one of them is wrong. So I would just check your work. Don't just make a wavy thing. Take my word for it that your graph should be, if everything is done correctly and your points are correct, just a U shape upward facing or downward facing. It should not be going waving up and down. Okay, -2, 1 is right there. -1, -2. Be careful with that one, that's down there. 0, -3. 1, -2. And 2, 1. Okay, and there it is. You can pop more points if you want to get a feel for it, but those 5 points and knowing that the graph should look like either upward or downward U should be enough for you to just draw a general shape. Make sure it's curvy there. Don't make it a V. It's not sharp and pointy there. But apart from that, I'm not super picky about the accuracy of a graph other than having some points. 5 is good for a parabola, and then just drawing the U shape through it. And just again, if you graph this point, if you had the point way down here, it does not go up and down. It means that point's probably wrong, and you should go back and check your work, especially the negatives. Okay, where was it? Right there. Okay. Anyway, parabolas, you need to plot points at this stage. That's the only way to approach it. Linear functions, you can do slope and intercept if you want, or you can plot points. There are other ways to handle it. There's ways to manipulate this equation and figure out where your what's called the vertex, the lowest point is, or the highest point, and what the shape is, and where the axis of symmetry is. But that's another algebra class, and they go into detail and spend a whole chapter on parabolas and manipulating that equation. We don't have time for that. I just wanted to get a feel for graphing functions, and I wanted to give you some variation and not just have them all be linear functions. Okay. Okay, last example. The value of a company decreases linearly from $5.4 million in 1993. This should look familiar because it's the same thing we did back when we were doing linear models. It is a linear model. To 2.6 million in 2001. Let T be years since 1990. And V of T the value in millions of dollars. Find the equation for V of T. Okay, most of the background to handle this we know because we've done this before. It is decreasing linearly. So it's going to be a linear model. Be aware it's going to be coming up in like a month or so where we have decreasing or increasing exponentially, and we'll have to look at a problem like that and read very carefully to determine whether it's linear or exponential, and we'll have to learn how to deal with exponential. Not yet, but it'll have to specify linear for us to do the process of finding a line. So this is the same problem we've been doing. The difference that I want to note is function notation. So we're still going to start working with function notation, but the work should be the same. But we'll get used to having this problem in the context of functions. Okay, how are you doing this? Same thing. You have T and V of T technically, although it's not important there, just as long as you know which one is T and which one is V. And there's 2 points involved, and since it's decreasing linearly, that means we're looking for a line that goes through these 2 points. And reference year is 1990, so I'm going to go through the process really quickly because it is something we've done before, and just highlight the differences on what we have to do differently when we're dealing with functions. Not much, to be honest with you, just getting used to a different notation. Okay, I got to do the slope. It's linear, so it's going to be a line. My slope is 2.6 minus 5.4 over 11 minus 3. I'm going to kind of blaze through the work because we've done it before. You got negative 0.35, yeah? I'm going to continue it up here. I will use y and x temporarily again. Same thing. Change the notation at the end after I work it out and get into slope-intercept form. Watch your sign. It's negative 0.35 times negative 3. I'm using the first point, obviously. I got 1.05. Okay, and I get a line. Y is equal to negative 0.35x plus 6.45 by finding the equation of a line between those 2 points, making sure I have my t and my v in the correct order, t being the independent variable. or in this case, the input variable, and v of t being the output variable, because we are now talking about functions. Okay, and that's not your final answer, because you need to give me an equation for v of t. V of t is like y. So you replace y with it. And your input variable is t, and that's like x. And you've done this before where you wrote v is equal to something something t plus something something. The only difference now is they're asking for it to be written as a function, and you're just giving the answer in function notation. That's all that's different about this particular problem. Okay, so you have a problem next in the homework, and I only have one follow-up question that's going to be similar to what you see in the homework. You're going to do several things with this, but once you get used to it, I think you're okay. Here, you're going to find v of 13 and explain what this value represents. I'm just going to put what this represents. I meant the value of the function, but it's also equal to the value of the company. Okay, explain what this represents. First of all, in theory, we could ignore all this and just treat this as one of the earlier problems from today, which is, hey, they give you a function, they're giving you input, you plug it in, and you get a value. Not as nice, not whole numbers, but we're free to use our calculators for this. Okay, so I'm plugging in 13. Let me highlight what I'm plugging in. So this is taking a function that we have, finding a function value at 13. Meaning you're plugging in 13 and getting an output variable, an output value. Negative 0.35 times 13. 1.9. Okay. So v of 13 is 1.9. That 1.9 has a meaning, so does the 13, and they want you to explain basically what the input and the output is. So it's a similar explanation to what you did earlier. It's just, again, function notation and thinking of inputs and outputs. It helps us to know our input variable is the t, defined in the problem itself. The output value is the value, or the output function is the value for that particular year. So our explanation is, and do I have room for it? Now I'm going to cram my explanation here. So the same explanation as you did in other problems in the last exam. There's a year involved, so in the year blank, and then there's a value of a company. The company was valued at blank $1 million. Something to that effect. I don't need complete sentences. I just want you to make sure you somehow explain the 13 and the 1.9. And not tell me the year is 13 or 13 years. We've got to convert it to a year. What year is year 13? It's 13 years since 1990. So you add it to 1990 and you get the year 2003. T is equal to 13. That's your input. That represents the year 2003. You're basically plugging in 13 so you can find out the value of the company in the year 2003. And the value was whatever your output. This function produces output. The v of t output is your company's value, 1.9 million. So that's it. Very similar to what we've done before. Just getting used to function notation. Input and output variables are like the t and the v of t, the year since 1990 and the value. Okay, that's all I got for this lesson. Like I said, it was short.